Hi everyone, today we will be analyzing a fairly simple BJT, a PNP BJT at that, given certain parameters. So here, just by looking at this, we are given VEB, which should be intuitive, which is just 0.7 volts. We also are given VC, RC, RB, and this is actually VE. Alright, so there's a few things we need to know. So we need to know our BJT identities, Ohm's law, and KCL. So more specifically, from the BJT identities, I know there's quite a lot of them, but we'll only need two for this problem. IE equals IB plus IC. IC equals beta IB. This should have been expected if you read that we need to calculate beta. That's the end goal there. So that formula should have been the first one that came to mind when reading the problem. We're also going to be using Ohm's law and KCL for the idea that current is conserved, and I think you'll be able to appreciate that when we get there. All right. So there are 5 steps that we are going to be following to solve this problem. I don't have to cover this. Firstly, we will determine VB from VEB and VE. And just a reminder, this is a PNP transistor, because we know that because this notation here, this right here signifies that this is the emitter. So from that, we know that this is a PNP. An NPNP is where this little arrow is down here instead, going down that way. And so the emitter would be down here. Okay, number 2, determine IB by Ohm's law. 3rd, determine IE using KCL. 4th, find IC from BJT identities. And lastly, find beta from, as you would expect, IC equals beta IB. All right, let's get into it. So first, we are going to determine VB. And so we're already given VEB, and again, it should be intuitive, 0.7 volts. And that's just equal to VE minus VB. And again, this is PNP, so it's not VB minus VE. That's for NPN. PNP is VE minus VB. And so that's going to, and we already know VE. From up here, it's given to us as 5 volts. So we can simply write this as 0.7 equals 5 minus VB. And that leaves us with VB equaling 4.3 volts. All right, step 2, determine IB by Ohm's law. So we can rewrite Ohm's law, as you know, as I equals V over R. And IB equals VB minus 2.5 over 20K. So that's this right here. So this is 2.5, and VB is up here. And so this is a pretty simple Ohm's law. And this gives us an IB of 90 microamps. All right, and thirdly, this might look a little complicated, but I promise it's simple. So we could rearrange. We could rearrange this whole circuit to look a little something like this. Now, this is rather informal, but it's just for the purposes of understanding what's going on. So we can just classify everything in here as just stuff, and this is the VEE. And down here is the ground, 500 ohms, okay? So basically everything in here is just stuff. So I represented that with this box called stuff. Now I do that so that we don't really care what's in here, as long as it doesn't connect to other components that connect to ground or anything like that. So this is, you could think of this as just something in series with itself. So IX is the current up here before going into stuff, and after stuff is the current IY. And now Kirchhoff's current law states that current is conserved, so there's no reason for current to leave this area of the circuit, because how could it? It only has 2 terminals, the 5 volts and the ground, meaning the current should stay constant throughout the whole time, from the start to the finish. So this lets us know that IX equals IY. So that being said, up here we know is the emitter, okay? And we can represent the emitter by, or the current by the emitter as IE And we can equate that to 2.5 over 500. Where do we get those numbers? We'll look up here, and you'll see that down here, at this node right here, the voltage is 2.5, and we're going over the resistor of 500 ohms down to ground. And like we said, that's going to be IY, that current. And IY is equal to IX from what I just explained. So IE is, in this case, IX and IY. IE equals 2.5 over 500, the volts over resistance of this segment. And IE equals 5 milliamps. All right, sweet. Next. So we got IE, which is fantastic, and I think this is where most people will get stumped. So IE equals IB plus IC. This is a BJT identity. And 5 milliamps, IE equals 90 microamps IB plus IC. Subtract the 90 microamps from the 5 milliamps, and we get IC equals 4.91 milliamps. All right. It's pretty easy from here on out. So we know the famous formula, IC equals beta IB, and we can rewrite that, of course, as IC over IB equals beta. And if you don't know, just a quick little refresher, that beta is simply the ratio between IC and IB. And we just plug in the numbers, 4.91 milliamps, which we found right here, and 90 microamps, which we found earlier in step 1. And that gives us B, or beta, equal to 54.55. All right, thank you for watching, and I'll see you guys next time.